Welcome back to the second session of measurement. Today we are going to study about a screw gauge. Today we are going to study about a screw gauge, and the topics are principle of a screw, pitch, least count and zero error. Now, principle of a screw. A screw has threads on it at equal intervals of length. When the head of a screw is rotated, it moves linearly along its axis. The linear distance which the screw moves in one complete rotation of its head is equal to the distance between two consecutive threads on it. This distance is called the pitch of the screw. So, the pitch of a screw is the distance moved by the screw along its axis in one complete rotation of its head. Generally, the distance moved along the axis is 1 mm or 0.5 mm on one complete rotation of screw head. So generally, the pitch is 1 mm or 0.5 mm. Now let's come to least count. If pitch of a screw is 1 mm or 0.1 cm and it has 100 divisions on its head, then on rotation of 100 divisions, that is one complete rotation, it moves ahead by 1 mm. Now suppose the circular head is moved ahead only by one division. In the figure you can see from 90 to 91. Then the distance covered on the axis will only be 1 mm divided by 100. That is 0.01 mm. This value is called the least count of the screw. So least count of a screw is the distance moved by it in rotating the circular scale by one division. From above discussion we have the formula for least count is equal to pitch of screw by total number of divisions on circular scale. Now to find the pitch. If we rotate the circular scale only once, then due to mechanical and personal error, we may not get the correct reading of the pitch. So instead we rotate the circular scale by suppose 10 rotations and then divide the linear distance covered by the number of rotations to get a more accurate value of pitch. Example, look at the figure below. The screw is rotated in the nut 10 times and it covers 10 mm horizontally. Here we see 10 complete rotations is equal to 10 mm. So one complete rotation will be 10 mm divided by 10, that is 1 mm. Therefore pitch here is 1 mm. In the second case, the screw is rotated 13 times and it covers 13 mm horizontally. So here we see 13 complete rotation gives 13 mm. So one complete rotation will give 13 mm divided by 13. That is 1 mm. Again here the pitch is 1 mm. Now a screw gauge is an instrument used to measure the diameter of a wire or thickness of a paper, etc. Usually up to an accuracy of third decimal place of a centimeter, that is up to 0.001 centimeter. A screw gauge works on the principle of a screw. Now some examples to calculate the least count. If a screw moves by 1 mm in one rotation and it has 100 divisions on its circular scale, then pitch is equal to 1 mm or 0.1 cm and the least count will be 0.1 cm divided by 100 because there are 100 divisions on the circular scale. That is 0.001 cm. Second example. If a screw moves 1 mm, that is 0.1 cm in two rotations and its circular scale has 50 divisions, as you can see in the figure, then the distance covered in one rotation will be 0.1 cm divided by 2. That gives 0.05 cm. Therefore, the pitch is 0.05 cm. And least count is equal to the pitch divided by the number of divisions on the circular scale. So 0.05 centimeter divided by 50. So least count is equal to 0.001 centimeter. Number 3. Example 3. If a screw moves by 1 millimeter, that is 0.1 centimeter, in 2 rotations and its circular scale has 500 divisions, then distance covered in one rotation will be 0.1 centimeter divided by 2, that is 0.05 centimeter, and the pitch is 0.05 centimeter. And so the least count will be the pitch again divided by the total number of divisions on circular scale, that is 0.05 centimeter divided by 500. So least count is 0.001 centimeter, that is 0.0001 centimeter. So we can also write it as 0.001 millimeter, or 1 into 10 to the power minus 3 millimeter, or 1 into 10 to the power minus 3 into 10 to the power minus 3 meter. The second 10 to the power 3 we have used for the milli, or we can write as 1 into 10 to the power minus 6 meter. This is also called 1 micrometer. Now basic construction of a screw gauge. In the figure we can see the thimble, which is actually a hollow cylinder. The thimble is attached with the screw. That means the thimble and screw will move together, and the thimble is over the sleeve, that is another hollow cylinder. The main scale is marked on the sleeve. Now in this figure we can see the screw and the thimble are fixed together, and the U-frame and the sleeve are fixed together. When the thimble is rotated along with the screw, it moves towards the left inside the nut, and the stud comes in contact with the nut, and here we see that the sleeve is now hidden completely inside the thimble. Now the formula for least count of a screw gauge is same as that of a screw. So least count is equal to pitch of screw divided by total number of divisions on its circular scale. Generally the pitch of a screw is 0.1 centimeter and it has 100 divisions on its circular scale. So the least count is 0.1 centimeter divided by 100. That is 0.001 centimeter. The least count of a screw gauge can be increased by two methods. One is decreasing the pitch. The second is increasing the total number of divisions on the circular scale. In the diagram given below, there are 20 divisions in 1 centimeter on the main scale, as you can see. So naturally one division will be 1 centimeter divided by 20 in the figure, and 500 divisions on circular scale. You can see in the figure. Here on one complete rotation of circular scale, the screw moves by one division on the main scale. Then it moves by that one division is equal to 1 centimeter divided by 20. So that one division is equal to 0.05 centimeter. Therefore pitch is 0.05 centimeter. So the least count is 0.05 centimeter divided by 500, which is the total number of division on the circular scale. That gives 0.0001 centimeter. It can be written as 1 into 10 to the power minus 4 centimeter, or 1 into 10 to the power minus 4 into 10 to the power minus 2 meter. That 10 to the power minus 2 is for the centi. That can be written as 1 into 10 to the power minus 6 meter, and that is 1 micrometer. So this is called a micrometer screw gauge. Now in the figure, how many divisions are there on the circular scale? Look at the two figures below. The first figure has 100 divisions. You can see from 95 you count, 95, 96, 97, 98, 99, and from 99 to 0 it is 100. In the second figure there are only 50 divisions. You can see from 45, 46, 47, 48, 49, and from 49 to 0, 50. So the second figure has 50 divisions. Now coming to zero error. If on bringing the flat end of a screw in contact with the stud, the zero mark of the circular scale matches with the baseline, the screw gauge then has no zero error. Now kinds of zero error. There are two kinds of zero error. One is positive zero error and the second is negative zero error. Let us understand it with the following examples. The first example of positive zero error. We can see here, on bringing the stud and the screw together, the zero mark on the circular scale, you can see the black zero on the circular scale, is below the baseline of the main scale. And we also see that the fourth division on circular scale coincides with the baseline. Therefore, zero error here is positive and is given as plus 4 into least count. That is plus 4 into the least count here is 0.001 centimeter. So that is plus 0.004 centimeter. That is a positive zero error. We have to put the sign plus in front. Now we come to negative zero error. The zero mark of circular scale is above the baseline. As you can see, the black zero on the circular scale is above the baseline, and the 97th division coincides with baseline. Therefore, the negative zero error, we have to put a minus sign. Here we have to be careful. We have to subtract the 97 from the total number of divisions on the circular scale, and since the total number of divisions are 100, so we'll write minus inside bracket 100 minus 97 into the least count, which is 0.001 centimeter. So it is minus 3 into 0.001 centimeter, that is minus 0.003 centimeter. So the negative zero error is minus 0.003 centimeter. Be careful to put the minus sign. Now correct reading when screw gauge has a zero error is given by observed reading minus zero error with proper sign. Now let's solve the question given on next page. Look at the figure. The screw advances by one division on the main scale when circular head is rotated once in this instrument before fixing the metal strip. Now we have to find here the pitch, we have to find here the least count, and we have to find the thickness of the metal strip fixed between the stud and the screw. So since in figure it is given one division is equal to 1 millimeter, look in the figure, you see one division is equal to 1 millimeter or 0.1 centimeter, and one rotation of circular head covers one division, so the pitch is 0.1 centimeter. Also in figure we see there are 100 circular scale divisions, so the least count will be pitch divided by 100, that is 0.1 centimeter divided 0.1 centimeter divided by 100, that is equal to 0.001 centimeter. So we got the least count, we have got the pitch. Now again we see in the figure, the circular scale is ahead of the 3 millimeter, that is 0.3 centimeter on the main scale when the metal strip is fixed. Therefore the main scale reading will be given as 0.3 centimeter. And we also see that the 94th division on circular scale coincides with the baseline. See in the figure, the 94th division is coinciding with the baseline. Therefore circular scale reading is given by 94 into least count, that is 94 into 0.001 centimeter. So circular scale reading is 0.094 centimeter. So the observed reading now is main scale reading plus circular scale reading, that is 0.3 centimeter plus 0.094 centimeter. We get 0.394 centimeter as the observed thickness. Now if the screw gauge has no zero error, then in that case the correct thickness is equal to the observed thickness, which we have just got as 0.394 centimeter. But suppose the instrument has a positive zero error of plus 0.004 centimeter, then the correct thickness is equal to observed thickness minus zero error with proper sign. So the correct thickness will be 0.394 centimeter minus inside bracket plus 0.004 centimeter, and that gives the difference as 0.390 centimeter. Now please note, here we have written 0.390 centimeter and not 0.39 centimeter because the least count is up to the third decimal place of centimeter. Now let us consider a negative zero error. Suppose this instrument has a negative zero error of minus 0.003 centimeter and observed thickness is 0.394 centimeter. We know the correct reading is observed thickness minus zero error with proper sign. So correct thickness is 0.394 centimeter minus inside bracket minus 0.003 centimeter. Both the minus make a plus. So the correct thickness is 0.397 centimeter. Now let us come to the main parts of a screw gauge. In the figure we can see the main scale, we can see the sleeve which is a hollow cylinder, we can see the thimble that is another hollow cylinder which moves over the sleeve, we can see the baseline, we can see the screw, the stud. Now whenever we have to rotate the thimble, don't rotate it directly. Always rotate with the ratchet, because on rotating with the ratchet, when the screw end and the stud hold the object, that means they gently hold the object, even on turning the ratchet, the thimble will no longer rotate and move forward and the screw gauge will not be damaged. But if you rotate directly by catching the thimble, then even after catching the object, it can press harder and that can damage the screw gauge. So always rotate with the help of the ratchet. Now solve these numericals. The pitch of a screw gauge is 1 millimeter and its circular scale has 100 divisions. In measurement of diameter of a wire, the main scale reads 2 millimeter and 45th mark of circular scale coincides with the baseline. Find the least count and the diameter of the wire. Second, when a screw gauge with least count of 0.01 millimeter is used to measure the diameter of a wire, the reading on the sleeve is found to be 1 millimeter and the reading on the thimble is found to be 27 division. What is the diameter of the wire in centimeter? If the zero error is plus 0.005 centimeter, what is the correct diameter? Number 3. A screw has a pitch equal to 0.5 millimeter. What should be the number of divisions on its head so as to read correct up to 0.001 millimeter with its help? That's all for the day. Thank you and we'll meet again in the next session. Till then, stay safe and goodbye till then.